Chapter 11, the next section is about solutions. So this is about taking substances and dissolving them in other substances, essentially. When a solid dissolves in a liquid, the solid breaks up and its particles move and fill the spaces between the particles of a liquid. So if you look at this, this is supposed to be like a kind of a depiction of how sugar dissolves in water. So initially you put it in and you can still see the sugar, but if you just leave it alone or else get a spoon and stir it, this is what starts to happen. Okay, this is where the particles mix with the water, and now what you have is a solution. Okay, so a solution is when I take a substance, so in this case sugar, I place it into a different substance, in this case water, and because the water will allow the sugar to dissolve, we say it's soluble, it will form a solution, and that's where the sugar particles are all mixed in with the water particles. Okay, so a couple of keywords here that you're going to have to okay, so the substance that dissolves is called the solute. So in the example up above, okay? So the substance that dissolves is called the solute. So in the example above, in the solution of sugar and water, sugar is the solute, okay? The substance that the solute dissolves into is called the solvent. So again, in that example, water is the solvent. Yeah. And then a solution is formed when the solute dissolves in the solvent. Okay, so we ended up with a solution of sugar and water. So you'll need to take that down. Okay, and there's a couple of examples here. So seawater is salt dissolved in water. So salt is your solute, water is your solvent. Sparkling water is a solution of carbon dioxide gas and water. So that's where the carbon dioxide gas is dissolved in the water. And a cup of instant coffee is a solution of coffee powder and water. So that's where the coffee powder is the solute and the water again is the solvent. So you can see that water is the solvent a lot. So a couple more keywords down here. Solids that dissolve are said to be soluble. Okay, so up here, the fact that the sugar dissolved in the water makes sugar soluble in water. And then if they don't dissolve, they are insoluble. Okay, and then just down the end here, if a solid does not dissolve, you'll either notice that it settles at the bottom, like I don't know what wouldn't, like a load of pebbles. If you threw a load of pebbles, they're solid, into a glass of water, they're not going to dissolve. Where will they be? They'll be gathered at the bottom. What can happen though, so say if it wasn't pebbles, say if it was muck or soil, it would end up floating through the liquid and make it cloudy. Do you know what I mean? Like it would dirty the water, and that's called a suspension when that happens. So a suspension is when the solid floats throughout the liquid and makes it cloudy. Okay, it doesn't actually dissolve in it, it just makes it dirty almost, obviously in my example of soil. Whereas certain things, I mean, even if you put soil in, like it would probably be a mixture of both, because if you had big heavy particles of soil, they would go to the bottom like the rocks, and then the kind of lighter particles would just cause the suspension to happen. Okay, so there's like one, two, three, four, five, 6 keywords there that need to be taken down. What is a solute? What is a solvent? What is a solution? What does it mean when a solid is soluble? What does it mean when it's insoluble? And what is a suspension? Okay, there's a bit there. Now, solubility. Okay, so it says it a little bit further down. So solubility is a measure of how much solute can dissolve in a fixed amount of solvent to make a saturated solution. Now, a few bits there. Okay, so solubility basically is if I were to take 2 liquids, or if I were to take the same liquid at different temperatures or something. So if you had if I had a beaker of water here at 20 degrees, and then I had another beaker of water here, and that one was at 60 degrees. Yeah? And I were to take a load of salt up here, and I pour the salt in here, and I pour the salt in here. Which one will dissolve more salt? Okay, so what will happen is I put the salt in, it will dissolve and dissolve and dissolve, and then it will get to a point where the solution is what's called saturated. See this word here? Okay, and saturated means it has enough salt, it has enough solute, the solvent can't dissolve anymore. And then what happens is the salt will start to gather at the bottom. Okay, you can this one you can try if you want to. I'm going to show you an experiment version of it, but like you can try this. I mean, I actually did this recently because I had a bit of a sore throat, and if you gargle salt and water, it's great for a sore throat. But like I literally threw a load of salt in and put water in, and was like shaking it, and couldn't get it to dissolve. Now, it clearly some of it had dissolved, but I was left with some. So what I had was a saturated solution. So my chemistry teacher husband was like, "I'll give it there," and he put it on the hob and heated it up, and then all the salt dissolved in, and I could get a really, really, really salty, very horrible tasting solution. Okay, so saturated is when it stops dissolving, when you've put so much salt in that the water can't dissolve it anymore. And what you will notice is that these two have different solubility. Okay, so the solubility is how much salt can they take before the salt stops dissolving. Okay, so temperature, it's written there somewhere. Temperature is one of the things that affects it. So if you increase the temperature, you'll be able to put more salt in than if you leave the temperature low. Another alternative would be if you were putting it into your 20-degree water and you just got a way bigger glass. Okay, more solvent. It's going to take more solute. Okay, so this would have a higher solubility because more salt will be dissolved in this liquid. This would have a bigger solubility because more salt can be dissolved. Okay, does that make sense? So solubility is how much solute you can dissolve in a solvent to make a saturated solution. Okay, now it says fixed volume here. I'm obviously just using this as a comparison just to give you an idea of what solubility is. Okay, these are important here. So these are things that affect solubility, or this is what solubility depends on. So the nature of the substance. So the substance you're putting in. So solubility will obviously be affected by the substance that you're putting in. So does salt easily dissolve in water? Or is it a substance that doesn't dissolve in water very well? In which case that will affect solubility. That will affect how much of the solute we can dissolve. What are you actually putting in? Okay, the volume of the solvent, like I said down here, if you have way more water, obviously it's going to take way more salt before you can't add any more salt. Okay, so that's what volume means, it's the amount of water. And then temperature, like I said here, you can try this one at home if you want. But yeah, if you add salt to water, at room temperature and you like, I don't know, boil the same amount of water and add salt, you'll be able to add an awful lot more salt to the hot one. Okay, so temperature of the solvent, which in my little example is water. Okay, so they're important, the three things that affect solubility. So yeah, I just want to show you this last two little things we're going to do here now. So in a solution where the solute is a solid, usually more of the solute will dissolve as the temperature increases. Okay, so that little sentence there. Now, obviously, we're not going to really be able to do this experiment. I'm not even going to make you write it up because it's a shame. There's kind of so much to it, like. But anyway, this is the outcome. This is what you need to know. Okay, so in a solution where the solute is a solid, usually more of the solute will dissolve as the temperature of the solvent increases. So here's a little graph if we have a look at it. So at 0 degrees, about 35 grams will dissolve. This is what's dissolving here. Solubility of sodium chloride in water. So sodium chloride is our solute and water is our solvent. Okay, so about 35 grams of sodium chloride will dissolve at water when the water is at 0 degrees. Bring the water to 20 degrees and now you're talking about 35.5 grams will dissolve. Bring it up to 40 degrees and you're talking about 36.5 grams. Bring it up to 60 and now you're up to 37 grams. Up to 80 and you'll get 38 grams. Bring it to the water boiling 100 degrees and you've got 39 grams. Okay, so you can increase the amount of sodium chloride that will dissolve in water by increasing the temperature of the water. Okay, so we'll just have a little look at how temperature affects the solubility of a solid. This is the right one, is it? Yeah.
Today, in this fun video, we are going to test how temperature affects the solubility of a solid solute. This is what you'll need: 2 beakers, salt, water, and a thermometer. First, add 50 grams of salt to the beaker. Now measure out 50 milliliters of water into the graduated cylinder. Put the beaker on the stove and add the water. Stir the salt and the water and turn on the heat. Use a thermometer to stir the solution and monitor the temperature. Heat the water to 95 degrees Celsius, stirring continuously. When it is heated, take the beaker of salt water off the stove and pour it through a filter. This will remove any undissolved salt from the solution. We now have a saturated solution of salt water. Now put the beaker into a freezer for an hour. After an hour, look in the beaker and take it out of the freezer. If you look closely, you will notice there is salt sitting on the bottom of the beaker. This salt precipitated out of the water as the temperature decreased. What this shows us is that more salt could be dissolved in the hot water than cold water. When the solvent cooled, it could not hold the same amount of solute, and the difference precipitated out. Let's test its temperature.
So you can see its temperature is -2 degrees. So yeah, he put was it 50 grams of salt and the 50 mils of water, mixed them, and when he was stirring, if you want to go back and watch it again, when he was stirring at I think it was about 54 degrees or something was on the thermometer, you could still see that there was a lot of salt that was still solid, so wasn't dissolved. And then when he got up to, what was it, 94, 95, 96 degrees, pretty much all the salt had dissolved at that stage. He did do a little process of filtration, and we'll talk about filtration as we go further on in this chapter. But that was just because the solution was saturated, so there was some salt that didn't fully dissolve even at 94 degrees. So he filtered that off. So what he had then going into the freezer was a fully saturated solution of where all the salt was dissolved in the water, but it couldn't take another grain of salt. Okay, if you put another bit of salt in, that would not have dissolved because the solution was fully saturated. Okay, then the beaker was put into the freezer, and when he looked at it after it had cooled to -2 degrees Celsius, a lot of the salt was back in solid form, and that was because as it cools, so if you follow this graph, when it went in the freezer, it was going in this direction. So as it cooled, it can the solvent can dissolve less solute. So the salt that couldn't be dissolved was kind of, he used the word precipitated, which we'll talk about, but it was basically thrown back out of the solution. Okay, it couldn't dissolve it anymore, so it just went back to being a solid. Is that okay? And then the last thing I want to look at is gases and temperature. Okay, so go back to big. Gases dissolve in water, but they show the opposite trends to solid. As the temperature increases, gases become less soluble. Okay, so less gas can actually dissolve as you increase the temperature, so it's better at colder temperatures. And this is oxygen in water. So you'll notice at 0 degrees, 7 grams of oxygen dissolves in water. When you go to 20 degrees, only, what's that, about 4.3 grams dissolves in water. Go to 40 degrees and only 3 grams. So at 40 degrees, you've like more than halved the amount of oxygen that will dissolve. At 60 degrees, it's down again at 2.5 grams. 80 degrees down to 1.2, and at 100 degrees, no oxygen will remain dissolved in water. It will all be pushed out of the solution. Okay, so I'm going to show you a video on this one as well.
Today, in this experiment, we are going to demonstrate how temperature affects the solubility of a gas. Let's start by boiling some water in a beaker. In a second beaker, add ice and water. Now pour a carbonated drink into a test tube. Place the test tube in the hot water. Notice the bubbles of carbon dioxide gas forming.
So that is carbon dioxide gas that is being pushed out of solution. So because it's hot, it can't, the water can't dissolve the gas. So it's pushing it back out of the solution.
Now place the test tube in the cold water. Notice how the bubbles slowed down? This is because gases are more soluble at a cold temperature. When a gas is kinetic...
Okay, so just to show you that the difference between when it was over here in the hot, that gas was being driven out of the solution. There was loads and loads of bubbles of carbon dioxide forming, because at hot temperatures, the solvent is not very soluble, so it can't hold the gas, so it pushes it out. Whereas when you went over to the cold temperatures, the bubbles slowed right down because it's much, much, much more soluble at those lower temperatures. Okay, so here we are down at the low temperatures, much more soluble. Is that okay? So I do have a small piece of homework just to make sure that you understand all of that. Okay, there's quite a bit there, so let me know if there's any issues. Okay.